jumping into the vector between 2 points. So previously we've looked at position vectors. So we've looked at, we can make different vectors here. So if we had A in this space, it would be 1 unit across and 3 units up. B here would be 1, 2, 3, 4, 5 units across and 4 up. So we're now looking at, in this point, the vector between 2 points. It means we want to look at here, if I was to go from A to B here, what would this vector here be? And so the idea behind this is, well, if I was going to go from A to B, okay, I could go, let's just take this one here. I'm just going to copy it and paste it over here so we can draw on it. Okay. Now, in this space here, if I was going to do this vector, go from this point here, so I'm at A, and I want to go to point B, we can consider this in vector operations by, if I go from A back here in the negative direction, okay, this here would be negative A. Let's change that to a... So negative A here would be this vector here on this triangle. Okay, that's if we're saying that A is this one up this other direction. Now, I'm noticing my notes are looking... So that way, if we were to go around this triangle here, let me just clear this vector here out. So this one here, we've said is negative A. And that gets us from point A back to the origin. So now we can go B. This vector here would be negative A plus B, this vector between the 2 points. Or we would write that as B take A. So this is sort of the point we're looking at here. And this is the definition. The position vector of B relative to A is from A to B equals OB, which was this B vector here, minus OA. So we take that one. So they've just changed the order there. And we take the individual elements, just like in the last section with vector subtraction. So for 2 points A and B with position vectors A and B respectively, so if we're going from A to B, you think here, if we want to go from A to B, and let me zoom out so you can see the function at the same time. So we're going to go from A to B here. We're going to go, well, negative A plus B gets me there. So negative A plus B is B take A. Or if I'm going the other way, B to A, I've got negative B, A. All right, let's look at the examples here. So we've got, let's change to light blue. So given our points here of negative 1 and 2, 3 and 4, and 4 and negative 5, find the position vector of B from 0, from the origin. So this is saying if we're at the origin, what's the position vector of B here? And this vector here, which we would denote with O to B, is going to equal, it's going to equal 3 in the x direction and 4. Now this one here doesn't use our formula. We just go 3 across and 4 up. So we've got that there. Sorry, I'm just double checking that I'm not sending us along the wrong space. We could use this as a vector 1, but it's a bit silly. 2 secs. All right, so if we're going to do B from A here, we're going to go this direction here. So this B from A is going to be O to A minus O to B, which will be OA is negative 1 and 2, minus O to B is 3 and 4. And so this means that this vector here, negative 1 plus 3, negative, why have I got negative 1? I've done these the wrong way around. I've made an error here. B from A means we're going to B from A. So I've actually stuffed this up because that shouldn't have been this way around. So let's just quickly erase that. So B from A means we're going this way. We're going to B from A. So B from A. Did I do this? B from A. So sorry. From A, we go to B. Gosh. There we go. So this means that we would do OB first minus OA, which will equal OB is 3 and 4 minus -1 and 2. So this here is going to equal 3 plus 1 minus -1 is 3 plus 1 is going to be 4, and then 4 take 2 is going to be 2, 4 and 2. So if we go here, we go 1, 4 across, which is -1 to 3, perfect. 2 to 4, up to, perfect. All right, next one, A from C. Let's get this one right. So this means we're going to A from C, which means from C we go to A. And so this one here is going to be C to A equals OA minus OC equals -1 and 2 minus 4 and -5. Okay, so this here is going to be -1 take 4 is -5, and then 2 take -5 is 2 plus 5, which is going to give us 7, which means we should go -5 in the x direction, so 1, -2, 4, 5, perfect, and we go up 2, 4, 6, 7, perfect. All right, let's just quickly jump into the next one. So example, AB is the diameter of a circle with the center C, -1 and 2. So it means we've got this point here in the center. This here, because it said this is the diameter, means it goes through the center, which means this and this are the same. And we've got this coordinate on the edge, 3 and 1. So we've got to find what B to C is. So if we consider this B to C using our vector operations means we're going to go OC minus OB if we consider the origin. So OC is -1 and 2. So we've got -1 and 2. Okay, and then we've got B equals 3 and 1 minus 3 and 1. So B to C should equal -1 take 3 is -4. And then 2 take 1 equals 1. So we've got this here from B to C here. It gives us this value here of -4. Now this one here, if we look at it, let's just pretend, what do we got? The origin would be somewhere, it'd end up being somewhere here, like x, -1, it would be in line here, and then it'd be sort of like down here. Let's pretend this is the origin here. So realistically, if we use, for this next question, we're looking to find the coordinates of A, which is this coordinate here. We can consider this, that if we were looking to find O to A, it would equal, I'm going to draw this, this is not to scale anymore, but this would sort of be O to C plus C to A. And now in our next step here, we've got, this is going to be -1 and 2 plus, now C to A, you'll notice has the exact dimensions as B to C. So we can put in our B to C here, which is going to be -4 and 1. And then here we're going to put, because CA equals BC. So that's meaning those vectors are the same. And so this means we can do this -1. So this is, you got to remember this is calculating OC. So -1 plus -4 is -5. 2 plus 1 is 3. We've got our coordinate here should be -5 and 3. And let's do a bit of patterning to check. So 3 to -1 is, this goes down by 4. By 4 again if we jump again. So perfect. And then 3, 2, 1, that patterns perfectly. Nice work.